Assalamu alaikum dear students, hope you are enjoying your winter vacations, but I'm sure that you are not giving up on your studies. So myself, your maths teacher, right now I'm here to take one of the chapters from class 7th book, and that is the chapter number 2nd of your book. And the name of the chapter, if it is visible on your screen, you can see the topic's name is, here it is, topic's name is friction, topic is fractions and decimals, chapter number 2 of your book. So, I hope you are aware that whenever we start up any new chapter in mathematics, first of all, we come to know about what we have to go through in that. That means the concept that we need to clear in that chapter. And concepts, different concepts in any chapter, we just use the word terminology for that. Terminology means simply the concept that you have to deal in the given chapter. Now, first terminology, the chapter's terminology, it will always start with every chapter's terminology. If you remember, we usually start with introduction. Then the topic, the first topic that we have to deal in this chapter is friction and its types. The second topic is comparing fractional numbers. Third topic it is operating fractional numbers. Then these three topics, they are included in the first part of the chapter, because the chapter, if you see, its title, that's fractions and decimals. Here it is, fractions and decimals. It has been split into two parts. One part is of fraction, another is of decimal. The first three topics here, these three topics, they will deal with the first part of the chapter, that's fractions. The second part of the chapter, that is decimals. You can see it on the screen. Second part of the same chapter includes the first topic. The second part of the chapter is decimal and its types. The way you will learn fraction and its types, in the same way you will learn decimal and its types. The next part, second part of the second topic, second part of the chapter, second topic is comparing decimal numbers. The way you will learn comparing fractional numbers in the first topic, in the first part of the whole chapter, then in the second part of the chapter you will again learn how to compare now decimal numbers. Next and last topic of the chapter that we are going to deal with in this whole chapter is operating decimal numbers. The way you will deal with operating fractional numbers in the first part, in the second part you will deal with operating decimal. And at the end we will have a combined summary. We will have a combined summary here for both the topics. So without wasting the time, let me come to the introduction of the topic. Introduction of the topic, if it is visible, I hope it's visible on your screen. You can see its introduction. Introduction. Now, its introduction, the first thing that will arise in your mind, that why do we need to learn friction? This is the common question that usually arises in almost all students. So why do we need to learn friction? So for that, let me consider here one of the shapes I will take. Let me take here a rectangle. It is a rectangle here on your screen. So the first thing that actually I am explaining here is this. Why fractions? Why fractions? Now for that I have just uh, constructed a rectangle here. I have taken the rectangle here. Now this rectangle, in mathematically, if you have to represent it with a number, it is considered to be a whole. One complete thing in mathematics is considered to be a whole. This is the whole. And whole in mathematics is represented by, remember, one whole in mathematics is represented by 1. Number 1 से हम उसको represent करते हैं. So this rectangle is a whole rectangle, nothing is missing in it. So it is a single rectangle, single complete thing in mathematics is represented by 1. Now, suppose I have to divide this rectangle into parts. I have been asked to divide it into, suppose, 8 equal parts. So let me divide it into 8 equal parts. Just wait on. Though they are not equal, but suppose they are all equal parts. Now this is one of the equal parts of rectangle. No. This is one of the parts of this rectangle. And similarly, this is another part of the rectangle. They are the 8 equal parts of the whole one. This one has been split into 8 equal parts. Now, the question is that the whole rectangle has been represented by a number 1. Now, how to represent these parts? I know this is one of the parts out of 8 parts. This is another part out of 8 parts. This is another part out of 8 parts. They all are a single part of the whole. Every part here is one of the parts of the whole. Now whole is denoted by 1. But how to represent this part? How to represent the 8th part out of 8 parts? How to represent one of the parts out of the 8 parts? This is the question that's put in the minds of mathematicians, and this concept, how to represent the part of something, how to represent the broken piece of something, how to represent mathematical numbers, this gives us the concept of friction. So if you have to represent this part, this first part, this thing square, you will see a small square here that I am placing an arrow outside here. You can see here this single part. If you have to represent it in mathematical number, how will you represent it? First of all, you have to see in how many parts the whole has been divided. Since you can see clearly here, the whole has been divided into 8 parts. So you have to first put a bar, and the number of parts in which the whole has been divided, you have to put that at the bottom of the bar. 8 parts. Now suppose out of 8 parts, I am talking about a single this part. I am talking about what is this part out of whole. How much is this part out of whole? So out of whole, since the whole has been divided into 8 parts, I have put that in below the bar. Now, the number of parts that you are taking in consideration. Here I am taking a single part. So, number of parts you have to write at the top of the bar. So, it becomes 1 by 8. So, 1 by 8 is a kind of number that you have neither seen on a whole number line, nor you have seen on a natural number line, neither you have seen the previous number, that is 18. 1 by 8 you have never seen it anywhere, because integers are all counting numbers and their negatives including 0. But this is neither a counting number this 1 by 8 is neither a counting number, nor it is the negative of a counting number, nor it is 0. Then what is this? This is a fractional number. Because it means out of 8 parts, we have focused on a single part. That means something has been divided into 8 parts. Some whole thing has been divided into 8 parts, and you have taken into consideration one part out of the 8. So this number here is a fractional number. Fractional number. Now, fractional number, we came to know it is something of the form a by b. A by b. But provided, remember, b can never be equal to 0. Why? We will come to that answer. So, this is the concept. Why do we need fraction? Suppose I am here coloring now out of 8 parts. I am coloring here 2 more parts. Now, how many parts in total have been colored? So, out of 8 parts, if you have to represent now this 3 parts out of 8 has been colored. Now, how will you represent it? You will represent it the way you have represented the bulb out of 4. So, 3 parts out of 8. Remember, 8 parts is a whole. It's not out of it, it's out of 8 parts. And 8 parts here represent the whole rectangle. Now, how will you represent it mathematically? Mathematically, you will write the fraction, you will write a bar, then you will put the number in which the total number of boxes in which the rectangle has been divided, the whole has been divided is 8. And out of 8, how many you are taking in consideration? You are taking in consideration 3 because you are coloring the 3. So 3 by 8 parts. 3 by 8 the part, so the whole. 3 by 8 parts of the whole rectangle have been colored. In the same way here, 1 by 8. 1 by 8 parts, when you take just one part, then 1 by 8 parts of the whole rectangle has been colored. Now, this is the reason why we need the concept of fraction. So, fraction in simple words, if you have to define it means part of a whole. किसी whole चीज का कोई हिस्सा. But remember, when you are talking about a part of a whole, it means you are dividing that whole into equal parts. Then among equal parts, each equal part is called the part of that whole. So see here, the rectangle I have taken, I have divided into 8 smaller portions, smaller blocks. But remember, all these 8 smaller portions are equal to 1 by 8. This is 1 by 8 part of the whole. This is also 1 by 8 part of the whole. This also 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 8 and 1 by 8. Now let us take one more example. I have just come to the second slide here. Now the second example I will take. Let me consider now here the circle I am taking. Have a. Oh, sorry. Now I am considering a circle here. The circle here. Now let me divide this circle. I am going to divide it into 4 equal parts. This circle, it is, let me first tell you, this whole circle, it's a whole circle. So it mathematically it will be represented by 1. Because every whole quantity, if it is single, is represented by 1. Now I am dividing it into 4 equal parts. So these are the 4 equal parts of the circle in which this whole thing has been divided. Now, since as per the previous logic that we have used in the rectangle, every part here, this part here, if I talk about each and every part now of the circle, This part is the part of 4. Part of 4. And in the same way, this is a part of 4, part of 4, this is a part of 4, part of 4, and part of 4. Now, how to represent mathematically this part? Now, we are coming to that. Have it. You have to put a bar there, and you have to see in how many parts the whole has been divided. And if you check clearly, it has been divided into 4 equal parts. Now, suppose I have been asked you to color 3 of the parts out of 4. So, let me color here 3 parts. This is the first part that I am coloring completely. The second part, this is the third part. So these are the 3 parts that I have colored. Now the question is, sir, how will we represent this colored portion out of 4 mathematically? So it's simple. You will represent it by how many parts have been colored out of 4? Out of 4, total number of parts in the whole has been divided. You will put it at the bottom. And at the top, you have to take in consideration the number of parts you are taking. You are taking 3 parts have been colored. So it will be 3 by 4. So 3 by 4 is a mathematical number, but it is neither a whole number nor a natural number nor an integer number. Then what is it? It is a fractional number. We call it a fractional number. Fractional. Now I hope you got the answer of your question, why fractions? Why do we need to understand fractional? Now we are coming to the first part of this first topic of this chapter, that is fractions and its types. I am writing here first topic, that is fractions, and its types. Fraction and its types. So first we should know what is a fraction. Now you, based on the above 2 examples, you should be able to create an equation by yourself. Now if we talk about a fraction if we talk, it simply means part of a whole. Part of a whole. Now it is a fraction. Fraction is a kind of concept that you can use in everyone. You can use everyone. But here we have it in numbers. That's why we need to learn now what are fractional numbers. Fractional numbers. Now, how will you define fractional numbers? Fractional numbers, you will write numbers that are of the form A by B. But provided B is not equal to 0. Why? We will come to it. You will just remind me later on why B is not equal to 0. Now, what is A called here and what is B called? What is this bar called? Now, for that, I am taking this A by B to the top here. Have a look. I am writing here A by B. Any number that is of this form is a fraction. But remember, this A is called the numerator. This line is called the fraction bar. And here, this B is called the denominator. denominator. So if you want to write the definition another form, you can put another form like that. Numbers that are of the form, done, of the form, in place of a by b, you can write numerator by denominator form. That is numerator by denominator. Provided denominator is not equal to 0. So fractional numbers, those numbers that are of the form a by b while b is not equal to 0, here is called the numerator and b is called the denominator. But remember, b can be any number except 0. That is denominator of a fractional number can never be equal to 0. Keep that in mind. Now, moving forward, this is fraction, and fraction if you have to define it, means part of a whole. And fractional numbers that are of the form a by b while b is not equal to 0, or the numbers that are of the form numerator by denominator form. Here you can see it. Here it is numerator divided by denominator form. Now examples I am providing you. Fractional numbers की examples देंगे बेटा. You can focus here. I can write examples here at the bottom. Below the fractional number definition. Examples I can write 3 by 5. What does it mean? It means some whole thing has been divided into 5 parts. Out of 5 parts, 3 parts have been taken. 3 parts out of 5. Next example, I am writing 7 by 2. Now here you will have a confusion, but this will be clear when we move forward in the chapter. Sir, something has been divided into 2 parts. Denominator tells us something has been divided into 2 parts. And out of 2 parts, how many parts have been taken into consideration? 7 parts. Sir, is that possible? We will come to that. Remember, there are types of fraction. And we will come to know these things will be discussed there and these things will be clear here. Then one more thing here, it is 5 by 5. 5 by 5 is also a fraction. We can call it a fraction. But if we talk about the actual definition, that means part of a whole. If we talk about this definition, then 5 by 5 is not a fraction. But mathematically, we can call it a fraction. How? We will come to know in the later part of the chapter. In the same way, 1 by 8, fractional number, extra. You can see none of the numbers contain 0 at the bottom. So they are all eligible to be called fractional numbers. So let me carry it on forward. I am going to the next slide. So we were here, this was the last slide, second slide. Now let me take you back to the first slide. What actually was the first topic here? It was fraction. I hope you got what actually is meant by fraction. Then we have its types. Now we will come to types of fraction. So let me take the types of fraction one by one in the next slide. So here was our second slide. Now the third slide here is about types of fractions. Now when we talk about the types of fraction, the first type that we usually take is unit fraction. What is a unit fraction? First we will deal with this. Remember, any fraction whose numerator whenever you are dealing with unit fraction, you have to focus on the numerator. That is the definition में जो हमने A लिखा है, उस पे focus करना. Now you will keep the definition of fractions in your mind like this: numbers that are of the form numerator, right, denominator. Because we will not talk as per the concept of A and B. Now we will take it as numerator and denominator terms. So what are unit fraction? Whenever it is unit fraction, first to say it is unit fraction. So even a single fraction can be a unit fraction. अगर एक fraction आपके पास होगा, that can be a unit fraction. When we talk about unit fraction, they are the fractions unit. Unit means something related to one. So a fraction, that means it will have a concept of one in somewhere. Now what is one here in the unit fraction? Remember, any fraction whose numerator is equal to 1, irrespective to what is the denominator. Denominator कुछ भी. Numerator अगर fraction का 1 हुआ, we can call that a unit fraction. So I am writing here a fraction having numerator one. वो फ्रैक्शन जिसका न्यूमरेटर 1 हो. I am giving examples here. Let me write few examples of unit fraction. I am writing 1 by 5. Next example, 1 by 8. Next example, 1 by 324. Next example, 1 by 2. Extra. You will have infinite unit fractions possible. So you can see all these fractions irrespective of their denominator. See, the denominator is 5, denominator is 8, denominator is 324, denominator is 2. Denominator can be anything. But what matters is the numerator. If the numerator of a fraction is 1, we call it a unit fraction. Now the second type of fraction. Second type we are coming to. Second type of fraction. Let me carry on. Here, so second type of fraction I will take here is like fractions. Or wait, we will first take, we will not go with like fractions. We will first take proper fractions. Proper fraction, it's not fraction, sorry. Whenever I will use word fraction, it means a single fraction can be a proper as well. Now what do you mean by proper fraction? Whenever we define proper fraction, we are defining it with respect to its numerator and denominator. So any fraction whose numerator is less than the denominator. Is the less than sign there? I am not putting it in short form. Numerator, here in the circle, if you put it in the circle with numerator, there is a sign less than. There is a less than sign here. Less than sign. And this is the denominator. Less than sign and this is the denominator. So those fractions whose numerator is less than the denominator are called proper fractions. So example, we will take 1 by 8, 7 by 39, 29 by 54, extra. You can take any example, but keep in mind that your numerator should be less than the denominator. Here you can see 1 by 8, 1 is less than the denominator, 7 by 8, 7 by 39, 7 is less than the denominator, 29 by 54, 29 is less than the denominator. But one important thing that you need to point out. Sir, you have written 1 by 8. 1 by 8 here. Sir, this is 1 by 8 here. 1 by 8. But 1 by 8 was a unit fraction as well. See, 1 by 8 is having two possibilities. It can be a unit fraction, it can be a proper fraction, because follows both conditions. It is numerator is 1, so it is unit fraction. So it is numerator is less than the denominator. So it is proper. 1 by 8. So there will be infinite such type of fraction. Every unit fraction is a proper fraction, but every proper fraction is not a unit fraction. 7 by 39 is a proper fraction, but it is not a unit fraction. But 1 by 324, here this, 1 by 324 is a unit fraction, but it is also a proper fraction. So coming to the next time, last time in this lecture, then we will continue in the next lecture. So third part type of fraction is improper fraction. Improper fractions are those fractions in which numerator of the fraction is greater than the denominator of the fraction, just opposite the proper fraction. Numerator of the fraction is greater than the denominator of the fraction. So wherever the numerator is greater than the denominator, we call them improper fractions. So example I am writing here. Example I am taking. Just take the, I will say, whatever proper functions you have written at the top, to take the receiver. And one more thing, sorry, improper fractions, you have to write numerator is greater or equal. You have to write a numerator whose numerator is greater or equal to, is the equal to sign. When you put sign like this, it is greater than, but if you put a line at the bottom of it, it means greater or equal. It can be greater or equal to. So example, here it is. Example is 39 by 7, 54 by 29, and I can write one more. Let me write here numerator is greater or equal to. If I write 5 by 5, remember 5 by 5 is also the part of, is also a kind of improper fraction. So we will continue in the next lecture. We will try to come way back to the definition that we have written. The definition that we have written there is mean fraction is part of a whole. That definition is completely fitted by proper fraction. Improper fraction, if you have to define improper fraction, you have to consider fractions as well. Then you have to, I will say, जो फ्रैक्शन की डेफिनेशन है उसको आपने थोड़ा बढ़ाना है. इट मीन्स अगर यहाँ पे हम देखेंगे 5 by 5 it means it is not a part. If something has been divided into 5 parts, all 5 parts have been taken into consideration. Why are they considered part? You have to take it whole. पूरे whole को ले रहे हो सर आप 5 by 5 में आप पूरे whole को ले रहे हो. Sir, it is not a part. It is a whole. Because 5 by 5 is equal to 1. So we will continue from this here onwards in the next lecture. See you there and don't miss the lectures. Take care. Allah Hafiz.